So yesterday we worked on the translating. You take something and you slide it. No turning, no flipping, no changing, no dilating. All it is straight sliding. Today, we're going to work on reflecting. So, we have a couple activities that we will end up doing. So it's important that you follow along. What is special about this word mom? It's big. Okay. Dusty? Okay, so it's one of those words that if I read it backwards, it's going to be the exact same. If I took the word mom and all I did, and I put it exactly the same right here, and I asked you, what kind of transformation did we do? You would have two options based off what we'd have right away. You might say it was translated. It just slid. Or, if it reflected along this red line, if I took it and I flipped it, like Dusty said, it would look exactly the same. That is why yesterday when we worked with our translations, I told you I really wanted you to, let's get down to here. When we graph, we want to put down our points. We always need to, come on, please. Alright, so that's why, if I go back, we go back to this one. Why any of these that we graph, we always put their new coordinate points on there. That is going to be what helps tell us if it just slid or if it was reflected. Today's learning goal is I can reflect figures in the coordinate point. Coordinate plane. We're going to reflect around a line. It's going to be our reflection line, okay? So the first one I did, Mom, when I wrote it around that red line, it flipped it this way. It came up with the exact same. It looked exactly the same. If I reflected it around that green line, does anyone think they could come up here and draw, what do they think Mom would look like right here if I reflected it? Oh my goodness, did you just say, what did you say? We got to work on that. I picked on fonts, but the wall. Alright, perfect. This would be wow. Whatever you said. So, if you open up your foldables for me, or your notebooks, let me see exactly where I have to be. Alright, in your notebooks, everyone, we should have this blue sheet. Well, actually, mine's blue. I'm sorry, yours is white. It says 2.2 Reflections Exploration. Okay, 2.2 reflections. Yours should be white compared to mine being blue. It would look exactly like this. That's up there.
Wait, what is it? 2.3?
2.2.
This one?
So, here's what I'm going to have you do. With someone that's right next to you, I want partner one to draw, and take your time, don't make a bad line. Try and make 3 coordinate points, draw straight lines. I want your first partner to draw a triangle. So, raise your hand if you're the triangle maker. Let's see who's doing this. So I'll have you 3 work together. So Kate's going to make the triangle. Britt, why don't you make the triangle? Jordan, will you work with Dusty quick? Jordan, draw a triangle. Isabel, make the triangle. Dulce, make the triangle. Dylan, make the triangle. Dylan, make the triangle. Donovan's going to work with them as well. Alright. If I did not call you, guys, I shouldn't have to talk over this. This is easy. If I called you, you should be drawing the triangle right now. So I think in one of the coordinates, in one of our, or not coordinates, quadrants, make it just inside here. Don't cross the lines. Just put it in there. Go grab it quick. Alright, if I didn't call you before, you are now partner 2. I want you to draw a rectangle. Or is it rectangle? Yeah, rectangle.
Wait, not that one. Anywhere? How big is that? Oh, never mind. You put him in wrong.
Please explain to my friend over here what he's doing wrong.
How big does the triangle have to be?
What kind of oh my god!
Oh, gentlemen, we're making this way too much. We're just being silly and we won't get through stuff. Okay. Here. All I need, gentlemen, I'm not going to keep stopping because you want to be silly. So, person, the third one can just do the rectangle with us. You guys have 3. Okay, so 1, I drew a triangle. Alright, so there is going to be my triangle. Now, what I'm going to do, I want to make sure we understand this. I'm going to come around and give you some transparency paper. Okay? What you do is you're going to put that right on top, and you'll see the purpose of transparency paper is it's letting me see right through my paper. Then, if I'm following instructions, it says, use transparency paper to copy your shape, the origin, and the XY axis. Remember, here's XY. I'm going to label that. That's X. This is Y. Here's my triangle. There's 0, 0. That's the origin. Okay, I'm going to come around and give everyone this, and I want to see you finish this part. Flip the transparency paper, align the origin and the XY axis. So,
It's not black. Probably I'll drop later. Jesus. I wanted to wait for you going to YouTube.
Can you have time?
Alright, so your first thing that you should be doing, Brett, have your planner out. I'm done. You're constantly just goofing around and talking out doing other things. Hey, if you're following instructions on this, we're learning about our reflections. So, following instructions on this. It said you were to copy this down as I did. I copied the y-axis, I copied the x-axis, marked the origin, copied my triangle. Now, flip the transparency paper. What it means is, I'm going to take my paper, I'm just going to flip it upside down, but I'm still gonna line up. I'm still lining up my x-axis. I'm still lining up my y-axis like it says. It said flip the transparency paper and align the origin and the xy axis. I want you to take a few seconds. You don't have to draw anything. You're just flipping it over right now. What is the line of symmetry? And when you reflect your figure, what do you notice about the sides, angles, and parallel lines? Parallel lines if you have the rectangle. So, I'll give you about 60 seconds. Turn and talk with your neighbor, and then we'll discuss it. Alright, real quick. If I took my figure and I flipped this like I did, what's my line of symmetry? Up here, what would have been my line of symmetry? Okay, my y-axis for mine. When I flipped it the way I did, it had to be y. Did anyone have x as their line of symmetry?
No.
Could I have x be my line of symmetry?
Yeah.
I'm going to put this back where it originally was. Can anyone come up and show me what it would look like if x was my line of symmetry? You have to go to my notebook underneath the document camera.
Is that right? I don't think that's right, Chief.
I don't know. Can I make this transparency paper be so I have x as my line of symmetry? No.
What's your problem? Oh, really?
10:53. So, no, it's right at the end of this one. Alright, guys, focus up here so we can finish. I need someone to tell me how can I make x my line of symmetry. Jordan, you think you know? Come up and try it. Aiden, focus in. This is going to be less. Harrison, I don't want you guys to. Gentlemen, I will easily just mark both of you and separate us. Jordan's going to try it. If he gets it wrong, I'll let you try. We'll see. You have to go to my document camera, pick it up, and move it. So, how are you going to change it so X is my line of symmetry? Okay, hopefully you watch that because you're going to be learning something that we're doing. Jordan was absolutely correct. Good job, Jordan. Yes. I'll give you something a little bit. So, our line of symmetry, if we're looking at this, what we're trying to learn about line of symmetry is when it is our Y, that's up and down. So I'm going to flip it left to right. When it was X, I flipped it up and down. The second part of the question right here says, when you reflect figures, what do you notice about the sides, angles, and parallel lines? Parallel lines if you had the rectangle. But what do we notice when I flip these? What do I notice about the angles and the sides? It just kind of turned them, it flipped them. Did they change though? Did I change my angles? Did I change my sides? Now on this one, we made X my line of symmetry. Look how far my point is from the x-axis. When I use that line of symmetry, how is it on the bottom side? They're the same distance apart. When you use a line of symmetry, your distance apart will be the same. The only difference is, what's the only big difference? Besides these being flipped, what could you tell me about the coordinates? Oh, I hope everyone heard that. So, side conversation full up. When we made X, Dusty said it pretty much perfect. He said, X is our line of symmetry, so our X coordinates stayed the same. This point was at -3. Well, same corner's at -3. That one's at negative something. Well, it's the same here. The middle point, same place on the X. He said, if you use X as your line of symmetry, X coordinates stay the same. The Y changed. How did the Y's change though? But specifically, they're going to change, but something very important. All they did was change the negatives. If this one was -3, 4, on this side it's going to be -3, -4. So that's what we are going to see. I want you to hold on to your transparency tape paper. I'm going to give you something after a while. We're going to keep them in our notebooks because we will use them again. But, oops. So, an important part here says reflection. I gotta see what we have to put in our notebook. Open up your foldable to the reflection section. Okay, opening to the reflection section. Okay, reflection section. It says you need to fill this out in there. Alright. You're going to fill this out. It says reflection is a transformation in which a figure is, we would write reflected. Across the line called the line of reflection. A reflection causes or creates a mirrored image of the original figure.
Where's the also part? Why is it the line of reflection?
Oh, we'll
not
just
the
leave
line
that
of
part then. Symmetry. It's good. Symmetry, because symmetry you wouldn't have to necessarily be flipping it, where this one reflection we will be flipping.
Well, couldn't you like just flip it and still be the same as if you flipped it like upside down?
Not necessarily, because if I did a line of symmetry, I could just slide it over and say this is exactly the same as this.
Like you could also do that if you flip it, then it's still like the same.
Yeah, but that's why they don't call it a symmetry. Because if I had a line of symmetry like this, and let's say I had this shape, if this is line of symmetry, it could be that. With line of reflection, it'd have to be something like that. With reflection, we know it's going to turn symmetry. It could be the same. It's a great question, though. Yeah, just leave that. No, I'm not sure what I want to do there. All right. So, let's see if we can tell. We have to be careful when we do these because a lot of times we'll make mistakes because visually we think yes right away. So, make sure you have this part filled out in your notes, your foldable. Is this in your foldable? Okay, that's what we're doing right now. Right, is it in your foldable? Okay, the first one. Tell whether the blue figure is a reflection of the red figure.
Yes.
I always think of pancakes when I think of reflections because I always think, yeah, I just take my spatula, I put it underneath, and I flip it. The nice thing is this line of reflection is going to tell me which direction I'm flipping. Since this is our X, I'm going to flip it this way. Would B be a reflection of the P?
No, that's no.
No, that'd be line of
Because you're not flipping it, you're just transferring.
No, this is
Oh,
a
I thought you were
reflection.
talking about B now.
No, oh, did I say B?
Yeah, you said B.
I meant blue. I'm sorry. So, yes. Hey, you looking for someone? If it's Dylan, he's in the restroom. If it's Dylan, he's in the restroom right now. I'll wait till next hour. Yep. Alright, so focus up here still. So I'm gonna take A and I will flip this pink one. If I flip, it's really hard based off what we're seeing. So that's where you're gonna use transparency paper like I gave you. Or you can use another piece of paper that you can kind of see through it and trace it in. Have your planner out and ready. I'm talking and you're just doing your own conversation. So we go to B. We see the line of symmetry or reflection is up and down, so I'm going this way. Would B be a reflection? No, this is a translation. How about number 1?
No.
How do you tell? Yeah. Reflection is up and down, so I should flip this way. This point, the part that's a little different, should have been on the bottom. So we would say no. Number 2. Well, I don't like that it's this way. So I have to turn my head some.
It works.
But yes. Okay, just like yesterday when we looked to see if things were translations or not, pretty simple. Now we're going to take it to a coordinate plane. So, here's what we're going to do. This is the important part that you have to see in your homework today. First, it says the vertices of a triangle are at, and this is pretty simple to do. Dusty has actually kind of told us the answer, but it should have been a preview on how we do this. My points are at 1, 1, 1, 4, and 3, 4, over 3 and over 4. Okay. Draw the figure and its reflection with the axis of symmetry at the x-axis, which means this one. Now, I actually was not going to explain this way, but I love how Dusty explained it.
Wait, is this the same one?
No, yeah.
Is this the same one as you?
Yes,
Yours?
yes.
Yeah, so that's what you should be doing it with me.
Attention, you would know.
So, I'm going to explain this exactly like how Dusty started, because I love his explanation. With my, if I'm going to say my symmetry is the x-axis, this is going to be key. If my x-axis is my symmetry, I'm going to put underneath here x coordinates stay same. So if you ever hear that, I'll say, okay, I'm going to flip on the x-axis. When you look at your coordinates, you're going to say, oh, then my x coordinates will stay the same. Which means when I go to A, these are my x coordinates. So they are going to stay the same. 1, 1. I want this to be thicker. Let's do this. 1, 1. Oops. 3. So my x coordinates stayed the same. What happens to my y coordinates though? Say that again. They're going to switch to negative. If they were negative, they're going to switch to positive. So they're just going to flip. And let's see if this works. So if this was, if I look at these, that was 1, this should be negative 1. Oh, I don't want to use red since that writing's red. Let's use this blue. Should be negative 1, negative 4, negative 4. Well, the way we can check, oh here, let me write this. Y coordinate flip. I'm going to put change sign. Well, let's check. This is how I would check this. If
I'm doing this, I'm going to look at my first point, A, right there. You should label these. A was at 1, 1. If I flip it, it has to stay the same distance away from my x coordinate, or x-axis. So it should go here. I shouldn't use blue since the original one's blue. Let's use orange. So I'd go here. That is now A. That coordinate is 1, negative 1. We have that. This one was 1 over and 1, 2, 3, 4. 1. I go to here. That would be B. That does make that coordinate 1, negative 4. I look at C. It's still going to be 3 because I'm just taking it and flipping it, but it was 4 away. So now it is 4 away. If I can find this. That is C.
Dusty's actually probably made it easier than what we would have done before. Normally, just like yesterday, we have to look at every verticity. When we did translations, we went for every verticity and follow the rule. Over 4 units, down 3. Each coordinate, 4 over, down 3. 4 over, down 3. With this one, when we're flipping, we're going to look here. This is the flipping down. I'm just going to keep the same distance from the x-axis. I love this part what Dusty mentioned. He mentioned it perfect. What if, though, I didn't use the x-axis and I used the y-axis? Awesome. I think we have one more of these. So, let's go ahead and try doing this one. We're going to put the points in. 1, 1. That's A. Pretty much. We get out at 49. We have 8 minutes. And C was 3, 4. So we're back to our very original problem. A, B, and C. If I follow Dusty's idea, they're telling us now to use the y-axis as my symmetry. If I use what Dusty had said, okay, now that I'm using the y-axis, that means my y should stay the same. So I'm going to go ahead and say, well, that would be 1, 4, 4. And according to Dusty, our x coordinates will become the opposite. So this one was, let's use this, was 1, so it should be negative 1. That was 1, negative 1. It was 3, negative 3. We check on here. Here's B. I'm going to do just B. Doesn't matter what order. B was up 4, but it was over 1, so I'm going to be over 1. That should also be B. I should probably move this B over some more. Okay, C was 1, 2, 3. So it would be 1, 2, 3. A would have been over just this one. And that made it easy. That's all we're having to do for reflection right now. When we are looking at line of symmetry, this is working really well today, where if our line of reflection is one of our axes. Can we ever see a problem though? What if it wasn't the x-axis? Would I still be able to just flip the numbers?
No.
So if you get what I'm saying is, what if I asked you to make the line of symmetry right, let's say on this one, I asked you on this blue triangle to make your line of symmetry right here. And I asked you to do it at positive 1. I want my line of reflection to be at y equals 1, or x equals 1. So I want it where I go over 1. It's no longer my y-axis, it's over 1. Would I still just flip all my things?
So, since the B and A are on the line of symmetry, you only put the C over and make it under the other shape.
Okay. What we're going to end up learning is this, though. This is taking it to the next step, because I think you guys are doing awesome. If I have this, and let's say I have my triangle like this, and I ask you not to do your reflection on the y-axis, but let's say I ask you to do it right here. What we're going to see is I'm still using it up and down, so the y, that means my y-coordinates will still stay the same. The y-coordinates would not change. The x, though, wouldn't just change and flip. We're going to have to look at flipping them, but then seeing what is this distance, and you're going to add or subtract it. Okay, so just get used to that for the future. We're not to that part yet. What I want you to do, we still have about 4 to 5 minutes. Let's look at your homework. For tomorrow. For tomorrow. 12 through 17, I know the number because we copied them from somewhere else. But on 12 through 17, same thing like yesterday. Just put Y or N. Is it yes or is it no? Are they a reflection of the figure according to the line of reflection? On 26, which letters look the same when reflected over the line? So what I'd have you do is just write it. Here, I'll give one example. C will look the exact same when I flip it. So just write C underneath. A does not look the exact same, so don't do A. But go through the whole alphabet and only do the ones, write the ones that are the same on the bottom half of the line. So when I reflect the letter, it looks the same. And then the last one, on 31, 32, find the coordinates of the figure after the transformation. This one says, pay close attention, it's challenging. Translate the triangle 1 unit right, 5 units down. You will do that first. I expect you to draw that triangle. Then reflect on the y-axis. Then you have to reflect it. Your last answer, that's some of the work. You're not even done yet. The last thing I need is I need to know what are the coordinates for S, R, and T. Okay? On number 32, my final answer, I need to know what are the coordinates for X, Y, W, and Z. Follow the instructions and then find the coordinates for each point. Okay, that is due tomorrow.